Assalamu alaikum student, this is Sana Zaid again with you. Hope you all are doing well. Here I am again with you with chemical equilibrium with the topic equilibrium constant, expression and its unit. Student, equilibrium constant is symbolized by Kc. So our SLO is student should be able to state the law of mass action in the end of this session. Before discussion of law of mass action, we are discussing here first what is active mass. So the formal definition of active mass is the concentration of a reacting substance expressed usually in moles per liter or mole per dm cube, or we can say in other words in molarity. Let's consider this simple reversible reaction in which AB react together to form CD in forward directions reaction, and in backward directions reaction CD react together to form again AB. Here student, you see A, B, C, D in square bracket. This square bracket shows our substances, either they are reactant or product, are taking in mole per dm cube or mole per liter, or we can say in molar concentration. So student, whenever we show our concentration in mole per dm cube or in molarity, this is called active mass. So what is law of mass action? This law is put forward in 1869 by two genius chemists, Goldberg and Wheat. According to this law, the rate at which a substance reacts is directly proportional to its active mass, or the rate of reaction is directly proportional to the product of the active masses of the reacting substances. Let's consider student this reaction again. So in this reaction, AB react together form CD in forward direction reaction, and CD react together to form AB in backward direction reaction. So according to law of mass action statement, here we can see the rate of forward reaction is directly proportional to the reactant, or we can say active masses of A and B, because in forward directions reaction our reacting substances are A and B. Similarly, the rate of reverse or backward reaction is directly proportional to the active masses of C and D, because in backward reaction our reacting substances are C and D. So these two expression or these two statement is actually express the definition of law of mass action. Other SLO is a student should be able to derive an expression for the equilibrium constant and its unit in the end of this session. Again, consider this example, this reversible reaction. According to the law of mass action, we know that the rate of forward reaction is directly proportional to A and B, reacting substance. This is reactant. When this proportionality sign is replaced by this equal sign, a rate constant is placed here, that is Kf. So our expression is like that. The product of Kf, A and B. Similarly, the rate of reverse or backward reaction is directly proportional to the active masses of product according to law of mass action. When this proportionality sign is replaced by this equal sign, a rate constant Kr is placed here, and this expression is become like that. Where student Kf and Kr, the proportionality constant, as I said in previous slide, this is specifically called specific rate constant of forward and reverse reactions. Student, we all very well know that at equilibrium state the rate of forward reaction is equal to the rate of reverse reaction. and both rate of forward reaction and rate of reverse reaction are symbolized by RF and RR. Whenever we place or put the value of RF and RR, our new expression is this. Now in next step, all rate constant become in left side and all concentration becomes in right side. So Kf over Kr is equal to Kc. This is called equilibrium constant. Whenever this Kc is placed in the place of Kf over Kr, so our expression is Kc is equals to concentration of product over reactant, or we can write this expression like that, Kc is equals to product over reactant, or we can say Kc, equilibrium constant, is the ratio of the active mass of product and reactant. So the formal definition of Kc according to the chemistry dictionary, equilibrium constant is a ratio of the product of concentration of products raised to the power of coefficient to the product of the concentration of reactant raised to the power of coefficient as expressed in the balanced chemical equation. So student, here what is raised to the power of coefficient? Remember student, all equation is not always balanced like that. This equation is not balanced form. Here we use small a, b, c and d use as a number of moles for balance this equation. So this number of mole or this variable is now comes as power of coefficient of product and reactant. So our expression is written like this, and or we can write also like that, Kc is equals to ratio of product over reactant. So the final formula of Kc is product of concentration of products raised to the power of coefficient and product of concentration of reactant raised to the power of coefficient. So student, let's write the equilibrium constant of the given reaction by using this formula. Let's consider when nitrogen reacts with hydrogen gas to produce ammonia gas. We write equilibrium constant expression by the help of this formula, product over reactant. Here our product is ammonia, so I write ammonia in square bracket, and this number of moles, that is 2, is raised to the power of coefficient of ammonia. Whereas our reactant is nitrogen and hydrogen, and I write it like that. Hydrogen having number of moles 3, so this 3 number of moles is raised to the power of coefficient of hydrogen. So like write it like that. So my Kc expression, or we can say equilibrium constant expression of this reaction is this. Okay student, in example number 2, we observe here carbon dioxide react with sodium hydroxide to produce sodium bicarbonate. It is an example of a reversible reaction. How we can write the expression, Kc expression or equilibrium constant expression of this equation? Yes, by using this formula, Kc is equals to product over reactant, and now I put these equations value, this product here and these reactant here. Here this equation is already balanced form, so here there is no power of coefficient appear in Kc expression or chemical equilibrium expression. How we can determine the unit of equilibrium constant? So student, it is very easy. If अगर आपको expression लिखना आ गया है तो you can easily find out the unit. According to the chemist, there are two situations in which Kc has no unit, and other situation Kc has unit. So let's first we discuss when Kc has no unit. So student, the reaction with equal number of moles on both sides of the equation. This is because concentration units cancel out. In this expression for Kc, or we can say the Kc of that type of reaction has no unit. For example, hydrogen react with iodine. 2 number of moles of hydrogen iodide gas will produce. Here we can see that in reactant side 1 and 1, 2 number of moles are present, whereas in product side 2 number of moles are present. So at reactant and product, both sides have equal number of moles. Say it, okay? Equal number of moles. So whenever we put mole per dm cube square and place mole per dm cube in the place of or hydrogen and iodine, so this value is cut down. So here no unit appear. Second situation is Kc has units. Student, the reaction in which the number of moles of reactant and product are not equal in the balanced chemical equation. So K has, of course, some unit. For example, nitrogen, hydrogen react together to form ammonia gas. So first of all, we write Kc expression or chemical equilibrium expression and place the unit mole per dm cube in the place of ammonia और प्रोडक्ट और रिएक्टेंट. सो यहाँ पे हम देखते हैं कि ये स्क्वायर इस 3 से कैंसिल होता है, तो हमारे पास 1 ओवर मोल पर डीएम क्यूब का स्क्वायर बच जाता है, रिमेनिंग आता है. और जब हम इसको सिंप्लीफाई करके लिखते हैं तो ये हमारे पास मोल इनवर्स DM6 की क्या यूनिट Kc का लास्ट में ड्राइव होता है. सो स्टूडेंट, लेट्स प्रैक्टिस दीज 2 इक्वेशन. In dinitrogen tetroxide, whenever decomposes to produce nitrogen oxide gas in forward reaction, and another equation is in which sodium chloride react with calcium chloride to produce sodium carbonate and calcium chloride. I hope you easily write the chemical equilibrium expression of these both equation and also derive their units. So this is all about today's class, student. Thank you so much. Please like, share and subscribe. Don't forget press the bell icon. Hence my all video you got first. Thank you so much and Allah Hafiz.